So we had the Universal Buffer Allocator for Linux workshop. That was this morning. I finished a presentation about that the previous day, asking what's next. Do we have any volunteer? Well, we had people showing up, so that's partly yes, at least. We had some discussions. I won't say we rehashed a discussion that happened in XDC 2016 and 2020, but we started from there. They discussed constraint resolution a lot, about how to get producers and consumers to agree, not just on formats and modifiers, but also on the constraints related to how to allocate buffers, where to place them in memory, and all that kind of things. We also covered a topic that was a bit new, where actually the proposal that James Simon worked on stopped. It's how do we handle the backend allocators. So we covered DMA heaps, which is something that's a bit more recent compared to previous discussions. And we have a few conclusions. So there is an interest. We need some kind of library. There was a few ideas being floated around. One was to start with an existing library and trying to expand from that, like GBM, for instance, or to try something new. No clear conclusion on that. We need some API. And, well, we do need someone to bootstrap this, but the most important conclusion is that we agree that we need to go for an iterative approach. The problem space is fairly big. The different parts are not necessarily extremely complex, but it's too scary for someone to just take that and bring it to completion. A couple of action points, mostly when it comes to the backend allocators and DMA heaps. It's to implement memory accounting in the DMA heaps as something that we don't have today. So that's one of the reasons that distributions do not allow access to DMA heaps at the moment. That's a big blocker. Everybody in the room thought that it shouldn't be very difficult, technically speaking, which was a bit scary because we were wondering why it hasn't been done yet in that case. So hopefully we haven't missed anything. And then once we have that, it means that we'll have access to DMA heaps in Linux distributions, and we can try to start pushing drivers to implement their own heaps when they have specific allocation requirements. Meeting notes, the raw meeting notes, I've posted them to the DRL Devil mailing list and Linux Media and cross-posted to another one. So hopefully the slides will be published and you can grab the link. But otherwise, go to the archive of the DRL Devil mailing list on law.kernel.org and you will find the raw meeting notes. They're a bit rough because they were raw. And that's it.
Hello, everybody. So first of all, thanks all for joining XDC and also being part of the workshop. We had a lot of great discussions today, very busy. I tried to summarize some of the discussion. We're gonna upload it in the website, so you guys can check it later with more details. But I guess we can start with the first discussion that we have, which was the one proposed by, sorry. Sorry. So yeah, some of the topics that we discussed about how to share drivers between v4L2 and KMS for bridget-like components. Then we have discussions about real-time scheduling, debugging, things like that. Now, next, display mux, HDR color management, and finally, the commit failure feedback. So the first one was how to share drivers between v4L2 and the KMS for bridget-like component. And the problem is we have some hardware device represented by a device tree node, for example, that are used in some case in a camera capture pipeline and in another case in the display pipeline, for example, scalars. And the question is, how can we have a single driver for that in the kernel that can be used for v4L2 and the DRM? We had many discussions, like a couple of ideas came from the conversation. Idea number one, we can have two different compatible strings depending on if the device is using in the camera or if the display pipeline. The problem of this approach came from the fact that this is some sort of a layer violation at the device tree level, and maybe maintainers might not be willing to accept that, but looks like we have a case for that in the past. Option number 2 is we can have a single driver where we can expose the device to 2 different abstractions, DRM bridge for the DRM and other one for V4L2 subdev for video for Linux. It is simple, but requires 2 different abstractions on top of the same device. And idea number 3, we still have a single driver, but we created a new abstraction in the kernel that unifies the RM bridge and the V4L2 subdev. The downside of this is we have a lot of work to get this design accepted, and we also have to migrate from other hardwares, which can be a challenge. So, but this solution looks like possibly a good one. The guy, if you want to discuss more about it, please follow up with Laurent Pinchart. So, yeah, next one. The next one that we had the discussion, it was about real-time scheduler. Basically, the problem that we have is some of the non-blocking page flips can, in a rare occasion, take a long time, and for that reason, get a CQ if the thread's doing the atomic commit in a real-time scheduler. Here we had like some sort of brainstorm how we're gonna maybe start to explore this problem a little bit more. One of the actions that maybe we can try is explore some way to get backtrace alternative. Some folks suggest maybe let's leverage a little bit more of ftrace during the busy to see if we can get more information. Another idea was we can explore the max amount that the thread can be in a busy to maybe see, like if we can control the timeout, maybe we can use a lower timeout and make it easy to reproduce some of the issues that they have with real-time scheduler. We can use it on Mutter. We can play with things like RT-Kit. If you need some help to set up RT-Kit and things like that, maybe you should follow up with Mike Condezo. And finally, for more discussion about it, talk with Jonas. Sorry, Jonas, yeah. Sorry. All right, next we have display mugs. We had a long discussion here how we're going to approach this, and we came up with some conclusions and ideas. So first thing, we want to explore more the idea of sharing DP aux and its implication. We also have some issues on how we're going to handle backlight in this scenario, so we probably can explore some of the available specs somewhere. We also have some brainstorm where we're discussing having compositor arm the mux switch via sysfs, send a mode set to the outgoing driver, then a mode set to the incoming driver. Sounds a potential solution. We also had an overall agreement that disable HPD can be part of the planned sequence for the initial panel. And finally, we had some questions, discussion about cross-sync, and we raised some questions such as the compositor is the DRM master for the entire mux switch sequence. So how can we guarantee that? Like, it's still an open question. We also need to make sure the design does not assume presence of a mux, because in the future we might have directly sharing over DP. So for more information and discuss, please follow up with Daniel Dedap.
So as usual, we'll talk about color management again. So we can say that after the meeting, we kind of agreed that we are ready to merge or at least organize ourselves to get the kernel API for color management merged in the kernel because it's not, of course, because we just decided it, but because we have covered all the needs, the basic needs to get it merged in the kernel. First thing is that we have already the AMD implementation, but also Harry also worked on attaching this proposal to the Intel implementation too. NVIDIA is already working on sharing their implementation according to Harry's proposal for the KMS Color Management API. And Qualcomm needs more time to get it into it, but they kind of say that the proposals seems okay. On the user space side, we already have experimental implementation from Queen that was shared by Xava already on the mailing list, and kind of validated that the proposal it's enough for what their needs. And GameScope has a draft that was Simon, the first one that shared, but and we are already using the driver-specific implementation on MD driver. So the next step is to move the driver-specific API to the KMS generic one, and we have some feedback from Weston, Mutter, and others that they are already exploring the proposal, and hopefully we will have something by the end of this year. But we kind of have feedback from the kernel side, GPU vendors, and the user space. But also, apart from that, we also have IGT tests that Harry also implemented. So we kind of cover all the aspect for this API. And yeah, so we are waiting for review advice and ACK advice on the last version of the proposal, and yeah, more feedback. And if you want to talk more about it or more information, first person is Eric, but also Xava, I, and many other, compositor and display driver developers are available for that. And yeah, the last part was kind of, just to, it's something that I forgot to mention, that we have more than 3 hours of a meeting. So that's why we have a lot of topics. But the last one was, I can say that was a mix of complaints and a brainstorm to brainstorming alternatives to get more information from kernel drivers of what is going on when we face a failure, a commit failure. So I think basically it was that. And yeah, that's it. Thank you. And thank everybody that joined us in this meeting.
Wayland has no slides because we do not know how to do display. That's all, thank you. Also, we were scheduled last, and it's only just happened, but that's fine because Wayland is agile, and we believe in rapid delivery. So we covered a lot of ground. The first and possibly longest and least surprising part was going through the governance changes that have been discussed recently and almost entirely approved. Those were focused around creating a little bit more mechanism to enable and also encourage people to be able to better find compromises between wildly different worldviews, and to be able to get things out there and make sure things don't tar pit. So if you're interested in those, Mike's written quite a bit about those on his blog, supergoodcode.com, and the merge requests are also all in the Wayland protocols repo. They're all tagged governance, and all of those have a lot of context going through things like the motivations and why we're putting them forward and what effect we hope they'll have. So yeah, there was a lot of consensus that it would be really good for us to enable people to get things out there more quickly. We demonstrated this by landing the FIFO and commit timing protocols, which some would say ironically are very, very late. And so one big user of those is Mesa, so we can stop blocking for EGL and Vulkan clients and give clients a bit more of a nice, smooth, consistent cadence. And we've got a bunch of implementations there, but also aiming at media. So that was a great turnout. And then we had a bunch of sidebars of issues that came up. So a big one was testing, where, you know, instead of one X.Org server that we all know and love or something, we've got like 1,000 compositors that we don't even know all of them, and some of them are loved, I suppose. Western is the good one, for the record. The reference. And so, yeah, there was a lot of discussion about how we build out some infrastructure to, you know, it's everything from conformance test suites to make sure that compositors are doing the right thing and obeying the protocol, and how we can build a common Wayland CTS. The answer to that is the usual. We need to probably talk a little bit less about testing and do more testing. You know, there's a couple of Wayland CTS projects which are really in need of people to pick them up and push them forward. So hopefully some good comes out of that. There's quite a long sidebar about security and some of the misconceptions people have there. You know, in that when Wayland protocols are very narrowly designed, that's usually because they're targeted at specific use cases, because it gives us more latitude to be able to do things in future and not box ourselves in, rather than because we hate freedom and we have really weird views about security. So we had a sidebar about that, but there is a security context protocol that Simon Sir worked on, which was merged a month or two ago. So if you're interested in anything that requires dealing with the security properties of external clients, security context is a great place to start. And then another one, which has been a huge issue for quite a long time, is accessibility. Both accessibility and complex text input falling under the umbrella of making Wayland-based systems more accessible to people who aren't able-bodied and working in Latin scripts. There have been a bunch of cuts at trying to do that, but nothing super systemic. So that one was more about trying to see if we can build up a body of people who are interested in and knowledgeable about accessibility with projects like Newton, and also people who are interested in and knowledgeable about text input. There's a little bit of momentum there, but it really does need people to get involved. So if that's a thing you're interested in, and then please go on, jump in. Little bit of discussion about some multi-GPU optimizations. To be honest, that was pretty niche. If you're interested in the DMA buff protocol, then there is, I think, maybe an MR. Yeah, there is an MR about that Xavier did. Am I missing anything?
Popcorn.
Sorry?
Popcorn.
Oh, yeah. And Connor and Mark brought popcorn, but they brought it about 5 minutes before it did sort of descend into shouting. Or 5 minutes after, was it?
We tried.
Yeah, you did your best. But it was nice. I know it was big, so thank you very much. And yeah, there we are. Thank you.